Alright, these are the solutions from the quiz today, the group quiz that would happen when I was not in class. So the first question, we're looking for the probability of a jack, that's event A, or a heart, which is event B. That's the probability of A plus the probability of B minus the overlap, where we count A and B. The probability of getting a jack is 4 cards out of 52. A heart is 13 out of 52. There's one card that is a jack of hearts that we have to subtract for being double counted, which gives us 16 out of 52, which is 4/13. The probability that a card is a jack or a queen, same thing, but this time we're looking at event C instead of event B. So we have probability of A plus the probability of C minus the probability of A and C. 4 jacks, there are 4 queens, there are no jack queens. So we get 8 out of 52, which is 2/13. The probability that the card is neither a jack nor a heart. That means it's of a jack, or if it's a heart, I don't want to count it. There's a few ways you can do it. What I would say is that this is the complement to what we calculated in A. Because if a card is a jack or a heart, I don't want to count it. So it's everything else. So we have 1 minus 4/13, which is 9/13. Part D, what is the probability that we get a heart given that the card is a queen? Well, how many queens are there? There are 4 queens. That's a given. How many of them are hearts? 1. A and B. Here we're worrying about A and B being mutually exclusive. A is a jack. B is a heart. Mutually exclusive. Can they happen at the same time? And the answer is that they do happen at the same time, so I should not write yes. No, they are not mutually exclusive. There's a jack of hearts. Alright, A and C. A is a jack and a queen. Are they mutually exclusive? Could I have a jack and a queen? Do they ever happen at the same time? And the answer is yes. They cannot both happen in one card. And to decide if the events are dependent or independent, I want to decide if one happens, does it affect the probability of the other? So I want to know something like, is the probability of A equal to the probability of A given C? So the probability of A, the probability of getting a jack, is 4 out of 52. And I want to know, is that equal to the probability of getting a jack given that I got a queen? Well, if I got a queen, there are 4 queens. How many of them are jacks? 0. Are those equal? No. That means that these two things must be dependent. So knowing that C has occurred affects the probability of A. On the back, we're looking at a problem that is a binomial distribution problem. So that's n choose k, you have the probability of something to the k, the complement to that, sorry, not q, p, to the n minus k for any specific amount. So when I want to know what is the probability that Brandon gets exactly 1 bullseye, that means that 1 bullseye happens once, a not bullseye happens 4 times, and that 1 bullseye could happen in his first shot, second shot, third shot, fourth shot, or fifth shot. You can plug this into a calculator, and we should be able to find out its value. My calculator appears to have frozen on the screen, so let me quickly calculate that this is the same thing as 0.4096. What's the probability that he gets at least 1 bullseye? So I could do the probability of 1 bullseye plus the probability of 2 bullseyes plus, and I could keep doing this, or that's way too much work. Let's do it as a complement. 1 minus the probability that he gets no bullseye. Well, that's 1 minus, I want to choose none of his shots to be a bullseye. He gets none of those 0.2, and he should get all the ones that miss. And that's equal to 1 minus 0.8 to the 5th, which is 0.67232. What's the probability that Brandon gets at least 1 bullseye in a round for 10 rounds in a row? Well, the probability he gets at least one bullseye in a round, we just calculated in B. And I want to know that he does that 10 times in a row. In any round, the chance that he gets at least one bullseye is shown in part B. And it's either that or he doesn't get at least one bullseye. So this is an example of another binomial problem. So I want him to get 0.67232. I want to raise this to the 10th power because I want it to happen in each of the 10 rounds. And I want to do 1 minus the answer that we just got, which is 0.32768. I want that to happen no times, and I want to choose all 10 rounds to be bullseyes. So I can take 0.67232, raise it to the 10th power, and I'll get that that's about 0.0189. If I roll a fair six-sided die, one of them is red, one of them is blue, what is the probability that the dice sum up to 6? We've seen this in the table with the sample space. There are 36 possible outcomes. 6 of those are a sum of 7, and I think I made a mistake on this in the solution that I wrote on the website. There are 5 ways to get a sum of 6. All right, what is the probability that you roll a blue 5 or get a sum of 6? Well, you get a blue 5 in 6 of the 36 outcomes. We get a sum of 6 in 5 of the 36. And there's one way if you get a blue 5 to also get a sum of 6. So we've counted that one twice. So we get a total of 10 out of 36, which is 5/18. In question 5, we're picking 2 slips of paper, and I want to know what is the probability for each of the following events. So I want both the numbers to be odd. So first off, we've got the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9. That means we have odd numbers. There are 5 of them, which means for the first one there are 5 out of 9 choices. Once it's gone, there are 4 out of 8 choices, and that's 20/70 seconds. 20/70 seconds is the same thing as 5/18. If you had wanted to, you could have said, well, there are 5 odd numbers, and I want to choose 2 of them. There are 9 total slips, and I'm going to pick 2 of them. What is that probability? And that probability, if you plug it into your calculator, is 10 divided by 36, which is 5/18. Same value. Either way was fine. What's the probability that the first number drawn is a 6? Well, if all I care about is the first number, the second number doesn't matter at all. So there's one way to get a 6 out of the 9 choices, and then I guess 8 out of 8 for the other ones, which doesn't really matter, so you just get 1/9. The probability that the first number drawn is greater than 6, so 7, 8, or 9, 3 out of 9 choices, and that the second number, and, so we're going to multiply, is less than 4, 1, 2, or 3 out of the remaining 8. That's 9/70 seconds is 1/8.